Okay, there's one detour we've got to make before we start looking further at the super stack, um, and that is to look at the overlay pattern. And part 7, the space for part 7 is called mapping stroke aliasing, and it introduces two concepts, and both of these are implemented using a common pattern called an overlay. So what we have here is a root space, the part 7 root space, and actually what it has inside it is a single endpoint, an endpoint called a mapper. So if I go and look at the address space and look at part 7, then what I see is there's a single physical endpoint mapper overlay. If I look at the structure diagram, I see that the mapper overlay is implemented in here. But the interesting thing is that just like an import, the mapper overlay knows about another space. In this case it's called inner space. Let's have a look at the detail of what the mapper is doing. So if we open up the mapper endpoints declaration, we see it's got two parameters associated with it. A configuration here, which we'll close just for the moment, but it also contains, somehow embedded within it, a space definition, just like any other space. So this is our inner space that we saw in the diagram, and lo and behold, inside this inner space we see there's an instance of our active1 endpoint. So we have an address space here, inner space, and it contains active1. So what is a mapper? Well, first of all, let's just take a quick look at the ROC guide and click on the overlay book just so that we can see a diagram. An overlay is a pattern that's embodied in a number of tools provided with NetKernel, and what it is it's basically a way of having an endpoint which is instantiated in one space, but when it's requested is able to issue a request through to a wrapped hidden inner space, a space that only it knows about. It's a fully legitimate first-class space, but there's no way to it from anywhere in the world. Not even the kernel inside NetKernel can make a request into this space. The only way to get a request to this space is to bridge it and route it through this endpoint. So a requester, in order to get to an endpoint inside this inner space, has to have its request accepted by the overlay, and then the request reissued into the inner wrap space. And really this is one of the most general architectural patterns you can have in an ROC system, and you can build very rich arrangements from this. And so what we see is the mapper is an instance of the overlay pattern, and the mapper's model is that when a request comes in to the mapper, it has a number of specified grammars that it can resolve with. If a grammar resolves, then there's a corresponding mapped request to issue onto the inside space. So we have a request on the outside with one identifier being transformed through a mapping to a request on the inside with another identifier. And let's see that in practice. So if we open up the configuration for the mapper, this is just a declaration for an endpoint, only this time it's a purely logical relationship. There's no physical class instantiated here, so this is a pure logical endpoint, and what we see is that we've given this endpoint the identifier of alias : active1. So if anyone requests alias active : 1, then the mapper will construct a request using the declarative request syntax for the identifier active : 1, and that request will be issued into the space that the mapper is responsible for. So let's have a play with the resolution trace tool to understand this pattern in more detail. Notice when I drop down the list of spaces here that I can issue a request into the mapping alias, or which is the name of the part 7 space, or I can issue a request into this subspace mapping aliasing mapper space. So that's the space that's contained inside the mapper. First of all, let's just try issuing a request. This is the diagram that we need to look at. Here's the space that contains the mapper. Here's the space that is contained by the mapper and that only the mapper knows about, and it contains our accessor 1 just here. So accessor 1 isn't in this space at all. So if I ask for active 1 in the primary top space in that diagram, what I get is it doesn't work. The resolution starts in part 7. The mapper overlay is tried, and the mapper overlay says no, I don't resolve that identifier. Okay, but the inner space here, mapping alias inner space, does resolve active 1. If you remember in our diagram, it contains accessor 1. So let's try and resolve that identifier in the inner space. And here we see, yep, it does. It resolves to accessor 1, the physical endpoint. And here we see that the request was resolved in the inner space and matched on accessor 1. So we see that there is an instance of this active 1 resource set inside this address space. We have active 1 inside here. It doesn't exist here. So stepping back out to the mapping aliasing space, remember that I declared a logical endpoint using a mapping that mapped alias :active 1 into a request that makes a request on the inner space. So what happens if I ask for alias active 1 in the outer space? If I issue a resolve request for that, then I find, yeah, the mapper overlay says it can accept that request. If I look at the resolution trace, we see it was in part 7 and it went to the mapper overlay. So now I'm going to turn on the visualizer. I should have cleared this. Turn on the visualizer. Now what happens if I ask for alias active 1 in the outside space? I get active 1. So what happened there? Here's the alias active 1 request, and notice that the first endpoint that gets resolved for this alias active 1 request in part 7 is the mapper overlay. So we can look at the details of how that happened. We see that the request was injected and it was called alias :active 1. The resolution occurred as we've seen before. We found the mapper overlay, and the mapper overlay looked in its set of rules and said, I have a logical endpoint definition for that. You've asked me to resolve alias active 1, and I do resolve it, but whenever that request is requested, I must issue a sub request, a new request for active :1 into the space which I am the overlay to. So what we see here is that alias active 1 fired up the mapper overlay because it resolved on its outside grammar, but then the mapper overlay issued a new sub request, and the sub request was for active :1. So now if I look at the resolution trace here, or the execution trace, you see that the mapper overlay issued the request for active :1. So it's been transformed. The outer request for alias active :1 has been transformed to an inner request for active :1. And then if we look at the resolution trace, we see that the request resolution was attempted in the inner space, and it resolved on accessor 1. So accessor 1 inside the inner space did its thing and returned us the active 1 request. So the mapper is a very powerful technology, because what it allows us to do is introduce aliases, so that endpoints in an internal space can be presented with a different identifier into another space, but also it allows us to create rules whereby we can have resource sets in this space configured so that a request in here will be mapped to some endpoint that's a executable endpoint, like a language runtime or that kind of pattern. So it's a powerful transformation of request identifiers, and it allows the two spaces to live in complete isolation from each other without any crosstalk. So this is a completely internal, isolated implementation space. The application is purely concerned with the identifiers in this space.